Assalamualaikum and very good night. My name is Muhammad Helmy. Today I will talk about this lab work 2, force, mass and acceleration. I'm from Group I. My name is Helmy, Muhammad Helmy. 14 Dem 19F 1007 77. In our team, in our group, we have Muhammad Fahmi, Syuraim bin Jamil and Muhammad Afiq Eisqhandar. Our objective is to understand the basic force, mass, acceleration and acceleration in Newton's second law. Second, know and use the equipment for the experiment. The third, analyze the result for the measurement. And lastly, to verify Newton's second law. Theory. Newton's second law of motion pertains to the behavior of object for which all existing forces are not balanced. The second law states that the acceleration of the object is depending upon two variable. The net force acting upon the object and the mass of object. The acceleration of object depends directly upon the net force upon the object and inversely upon the mass of object. As the force acting upon an object is increased, the acceleration of object is increased. As the mass of object is increased, the acceleration of object is decreased. According to Newton's second law, acceleration is produced when a force acting on mass. The greater mass object being accelerated, the greater amount of force that needed to accelerate the object. In this particular, we using formula F equal to ma, where the F is force, m is mass, a is acceleration. Speed is the rate of change in the distance. In other words, it is how fast the distance change in one unit of time. In mathematics, displacement can be calculated from the following formula. For the formula, we using velocity v, distance d over times t. The unit we use is m over s. Velocity is the rate of change in displacement. It is how fast the displacement change in one unit of time. And then acceleration is change of velocity. Acceleration a equal to velocity v over time t. And then we go to the apparatus or equipment. First, we using a scale, set of unit balance. First, we use a scale. Second, we use set of weight balance. And next, we use a stopwatch. And then lastly, we use a meter rule or potato set. And the safety, and then we go to the safety pre-countings. This first, please do not do experiment without lecturer supervisor. And then after the finished experiment, please arrange equipment. And then we go to the procedure. First, set up the apparatus and material as shown in figure 1 in here. And then record a value of m1 and distance of h are constant. The height is constant, height. And then release a system of from 0 to n and according time t when the m1 is dropped. Repeat the procedure for different tests. Thus, and next repeat the procedure with different value of m1. Lastly, record the result at the table below. This is the result table. My friend is already talk about this. And then we go to the result for the T1, test 1 and test 2. At the test 1, we can see the difference in between the two graph is the height. When the height is increased, the velocity will decrease so rapidly because the gravity force is because the gravity force is increased. And down below we use x axis is time in second, and the velocity we use v. For velocity, the test 1 I use 0.025, and the test that for test 1 and the test 2 the velocity I use 0.05. I think that's all for me. I hope you like this video. Thank you and assalamualaikum.
Assalamualaikum. Very good afternoon, everyone. My name is Fahmi Syuraim. I'm from Group I, and today I will be talking about result data from the force, acceleration, and mass experiment. From the lesson memory, we could see that, as you see from the experiment, the data that have to be collected is really recorded. For the test one, the mass is 100, 50, 20, 10, and 5, which will be converted into kilogram, would be 0.1, 0.05, and 0.2, 0.01, and 0.05 kilogram. For the times taken by the stopwatch, we could say that for the 0.1 kilogram, for the first time, for the first stopwatch, or the time taken, it shows 0.97 seconds. The second one is 1.46 seconds, and for the third one is 0.97. And the average for the time taken by the 0.1 kilogram is 1.13 seconds. For the second test, we will be conducting the experiment with 50 gram or 0.01 kilogram weight, resulting in 1.45 seconds for the first time taken, 1.21 seconds for the second take, and 0.91 for the last and third take. So the average that we could recall is 0.90 seconds. For the third experiment, we take the 20 gram or 0.62 kilogram weight. The time recorded is 1.13 seconds, 1.53 seconds, and 1.21 seconds. And the average for the time taken is 1.29 seconds. For the third experiment, we use the 10 gram or 0.01 kilogram weight, resulting in 1.04 seconds, 1.28 seconds, 1.29 seconds, and lastly, the average for the time taken is 1.20 seconds. For the last and fifth experiment, we use the 5 gram or 0.05 kilogram weight, which has shown that time taken is for the first take is 1.45 seconds, for the second take is 1.61 seconds, and lastly 1.36 seconds. We could conduct that from the time taken, the average is 1.47 seconds. Be advised that the height they use for the experiment is 26 or 0.2 meters. For calculating the velocity, we use the formula of height divided by time. For the first 100 gram weight, we got the velocity of 0.18 miss 0.18 velocity. For the second experiment of 50 gram, we got the 1.17 velocity. The third is 0.60 velocity. Fourth is 0.17 velocity, and lastly 0.14 velocity. For the acceleration, we take the velocity and divide by times taken, or the average time taken. For the first experiment, we got the total acceleration of 0.16 velocity over time. For the second one, we got 0.14. Third one is 0.12. Fourth one 0.14, and lastly 0.1. Moving on to the test 2, we use more height for the test 2, which is the TCM or 0.3 meter. For the mass, we use the same mass from the test 1, as you can see here, 150, 20, 10, and 5. Also 150, 20, 10, and 5 gram for the test 2. The average time taken, we could say for the 100 gram, the time taken is 1.05, the second one 0.96, and lastly 1.30 seconds. And the average for time taken for 100 gram is 1.05. For the third one, the first time taken is 1.13 seconds, second one 0.88 seconds, and third one is 0.89 seconds. And the average for time taken for the 50 gram weight is 0.97 seconds. For the third one, we use 20 gram weight, which is resulting in 0.72 seconds for the first time taken, 0.8 for the second, and 0.97 for the third time taken. And we could conclude that the average taken by the 20 gram is 0.83 seconds. For the fourth one, we use 10 gram or 0.01 kilogram. For the first time taken, it is 1.06. The second one is the same, 1.06, and the last one is 1.21 seconds. And the average time taken by 10 gram is 1.11 seconds. For the fifth and last one, we use the 5 gram weight, which also we convert the kilogram into 0.05. The first time taken is 1.21 seconds. Second is pretty much the same, 1.21 seconds, and for the third one is 1.41 seconds. And the average time taken is 1.28 seconds. Just like for the test one, we use the same formula in calculating the velocity and acceleration. You can see here for the 100 gram, we divide height by time taken, which is 0.3 over 1.05, which is resulting in 0.29 velocity. The one is 0.31 by dividing 0.3 to 0.87. For the third one, we got 0.36. For the fourth one, we got 0.37, and then lastly, for each one, we got 0.33. For the acceleration, we take the velocity and then divide it again by time taken. For the first one, we got 0.29 over 1.05, which is related in 0.28 height over the second per square. For the second one, we got 0.32, one 0.43, fifth one 0.34, and lastly the fifth one is 0.80. From the result and data, this we could conclude in this session. Based on test 1, we could see that the graph is moving down slowly since the height is 0.2 meter. And because of this, the velocity is about a meter. You see here, almost constant. So the time are longer compared to test 1. Time is shorter compared to the test 1. It is all because of the from the test 2. You see that the height used is 0.3 meter, which is slightly higher. So making the time that taken are shorter compared to test 1, and the velocity is slightly lower. So I will be stopping here. Thank you for watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Eisqhandar and my number registration is 14-19F1079. So today I want give explanation about discussion based on this report acceleration. So based on test 1, the graph is moving down slowly since the head is 0.22 meters, and because of this the velocity is about to horizontal, so the times are longer than test 2. Then for test 2 the graph decrease rapidly and the velocity is slightly lower since the head is 0.3 meters and the times are shorter than test 1. So we go to the conclusion. In conclusion, Newton's law of motion was proved in this lab based on the data obtained based on the graph from experiment. It can be determined that force is proportional to acceleration based on the curve of the graph increasing and decreasing as the mass attached to the force sensor was moved further and closer to the motion sensor. The value of this experiment were close. The theoretical values obtained, which indicate little error, was performed during the experiment. The data from experiment 3 revealed that when an object is dropped from the same head will not affect the acceleration. So reference and appendices. I found another information from this internet, www.studocu.com, www.ebi.ec.uk, and www.precisa.co.uk, and from another books such as A History of Vector Analysis and Newton's Law by Joshua F. Whitney. So that's all from me. Thank you.